one. What about Fe2O3, Cr2O3, Al2O3, and okay, this is and TiO2 nature. So in the previous lecture, if you remember, I was talking about the nature of oxides which are formed in the steel making process. Hmm. Because we are purging oxygen into the molten iron, or yeah, obviously the impure molten iron, and we are generating oxides out of that, because the molten iron contain lot of impurities which preferentially or selectively react with oxygen to form oxides. And I told you about the nature also, whether they are acidic or whether they are basic. Hmm. So now, can you tell me about this nature of this? Can anybody tell me about Fe2O3, Cr2O3, Al2O3? What will be the nature? Whether they are acidic or basic? If you remember, SiO2 is acidic or basic? Acidic, right?
Acidic.
Yeah. And P2O5 is
Acidic.
acidic. Very good. And what about FeO and MnO?
Basic.
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 Very good. Yeah. So can you tell me about Fe2O3, Cr2O3, Al2O3? How to identify? I told you in the earlier lecture how to identify whether an oxide is basic or acidic.
Non-metallic
Sorry for
material.
Non-metallic oxides are what?
Acidic.
Acidic in nature. Very good. And metallic oxides are basic, right? So that is one of the way. But there is another way to decide whether it is acidic in nature or whether it is basic in nature. That is another way I'll tell you today itself. And there is an important point you have to remember. Certain oxides are amphoteric in nature. Hmm. You might have heard this word in school days, amphoteric. Amphoteric oxides means those oxides will behave both as acidic and basic, depending upon the situation. Right? Suppose if the slag is of acidic nature, that particular amphoteric oxide will act as basic. It acts as a base. And if the nature of slag is basic in nature, then the particular amphoteric oxide will act as acidic, just opposite to the nature of slag, right? And just have a look, this Fe2O3, Cr2O3, Al2O3 are amphoteric oxides. You have to remember, these are the examples of amphoteric oxides. Fine. You can get a question from this during your placement interviews or during the written test. Fe2O3, Cr2O3, Al2O3 are amphoteric oxides. They're neither acidic nor basic, basically. Fine. But what about TiO2 here? TiO2 is acidic, right? Now the question is how to identify whether an oxide is acidic or basic. One point I told you in the previous class on the basis of whether it is metal oxide or whether it is non-metal oxide. But another point is you have to remember the number of oxygen matters here. Right? If the number of oxygen is higher, then it become acidic. If the number of oxygen will be lower, it become basic. And if it is near to the, it is it is in middle, it is amphoteric. So TiO2, Ti is 1 but oxygen is 2, so it is, that's why acidic. Just have a look, P2O5, phosphorus is 2, oxygen is 5, higher, very high, so it is highly acidic, that's why. SiO2, silicon 1, oxygen 2, so higher number of oxygen, so it is acidic. But with MnO, 1 manganese, 1 oxygen, so that's why it's basic. FeO, 1 iron, 1 oxygen, it is basic. And just in between this, Fe2O3, Cr2O3, Al2O3, they are in oxygen amount is in between, so that's why it is amphoteric, right? Am I clear to everyone or shall I repeat?
Sir,
Yeah,
but in Fe2O3, Fe is two in number, and
yeah,
O is three in number. So
yeah.
of course it will
Yeah,
uh,
this
be
is
acidic, right?
huh. No, not exactly, because see here iron is also in sufficient amount, right? That's why. If it is Fe, for example, if there is no compound such as FeO3, but if there will be a compound of FeO3, then it will be acidic, because one iron, three number of oxygen. Just CF, Cr2O3. If it will be CrO3 only, there is no compound such CrO3. If it will be CrO3, then it will be acidic, because three oxygen, one chromium. But here, amount of metal and oxygen are in the equivalent amount nearly, right? Not so difference. But
Yes,
this
sir.
one, TiO2, here only one titanium but two oxygen. So it is acidic. That's why I'm saying.
Okay, sir.
Suppose there is a compound such as Ti2O3, for example. There is no such compound, but if there will be a compound Ti2O3, then it will be amphoteric, basically, not acidic.
Okay, sir.
You understood now? Fine.
Yes, sir.
This concept will help you if you are dealing with hydrometallurgy also. When we are dealing with hydrometallurgy, suppose you have an ore and you want to dissolve it in an acid. So you need to check whether that ore is basic or not. If the ore will be highly basic, you can easily dissolve in acid. It will react easily, right? But if the ore is amphoteric as well as it is acidic in nature itself, it will take more time to dissolve in acid, or it may dissolve in acid easily. The concept is clear,
Okay,
right?
sir.
What I meant to say.
Yes, sir.
Okay, next, this one, this slide. So this slide basically talks about starting from steel making to the end of the product. So first is, this is the sequence. Just see the arrow marks. The sequence is, the first step in steel making is called primary steel making. You have to remember. The second step is called secondary steel making. The next step is continuous casting, and the last one is called finishing operation. So primary steel making simply means making crude steel, steel in a large amount. From what? From impure iron. It may be scrap, it may be your DRIs, that is sponge iron, or it may be your hot metal. So just converting hot metal, DRI, or scrap into steel is called primary steel making, right? And secondary steel making means after making crude steel, still its chemistry is not uh, a desired one, or it is not, which is not sellable. You cannot sell it directly. You need to modify the composition first, then only you can sell it to the customer. That means in secondary steel making, basically we are controlling the composition of the steel. You can add some alloying element, you can remove further impurities if you want, those things. And more homogenization also done. Homogenization means in terms of temperature and compositions. So desired steel is produced in secondary steel making. You have to remember in term of composition. What kind of composition? Suppose you want low carbon steel, or whether you want medium carbon steel, whether you want high carbon steel, or suppose you want a particular alloy steel. So all, it should be uniform in composition also, and the steel should be uniform in temperature also, right? So that kind of steel can be produced during secondary steel making, right? And that is also called ladle metallurgy. Sometimes you may not get confused between this. So if somebody asks you what is ladle metallurgy means it is secondary steel making process, because secondary steel making process are not carried out inside the furnace. These are carried out in a ladle, basically torpedo ladles, or some particular ladle will be there, not exactly torpedo ladle. Some other ladles will be also available. Some ladle kind of furnace will be available, that is called LRF, ladle refining furnace sometimes, but it is not exactly furnace, it is a ladle actually. Every facilities will be there, right? Then next is continuous casting. So once the desired quality of steel is formed, we can cast it. Cast means we can solidify it to give a desirable shape. We cannot, right? We can give a desirable shape. Basically, bloom, billet, slabs. These are produced mostly during this continuous casting. So that's why it is solidification and shaping. And last one is finishing operation. Finishing operation means once you generate billet, bloom, slabs, they have significant amount of what thickness. So we need to reduce the thickness to very small to get any particular shape. Like we can get any coils, we can get bars, right? Rails, angles, channels, any desired shape we want, which the customer will take, right, finally. And we can give some heat treatment to it, because you understand, because if you give heat treatment to the steel, the property will change, the required property you can achieve. So that is mechanical working and heat treatment, final operation. So these are the mechanism here, operations, process, and mechanism involved. So you can see in primary steel making process, the main mechanism is oxidation, right? Because we are blowing oxygen into the hot metal and we are oxidizing the impurities, right? That is oxidation process. And in secondary steel making process, we are doing lot of things. We are doing deoxidation. Deoxidation means we are removing the dissolved oxygen. Excess dissolved oxygen will be there in the steel. That should be removed. If it will be not removed, that creates problem during the solidification process, and it decreases the quality of steel also. Similarly, dissolved gases also. Degassing. Degassing means removal of dissolved gases like nitrogen, hydrogen. There will be also, this steel also contains dissolved gases that should be removed. Because that creates problem during the continuous casting, right? They create blowholes, surface blows, any porosity will be there, right? Which are not desirable in the final product. And alloying, if you want any alloy steel, you can add alloying elements, different alloying elements in form of ferroalloys. Basically, alloying elements are added in form of ferroalloys, you have to remember, not in a individual form. That means it is a compound of iron, or it is an alloy of iron and other alloying elements, right? And external treatments, any external treatment, if you want, suppose you want further dephosphorylation, if you want further uh, desiliconization, or if you want further decarburization, you can do that. Those processes can be done also. Then argon nitrogen purging, these are inert gases actually. Argon and nitrogen purging means we are actually purging inert gases into the molten steel. What can you tell me, what may be the reason of purging these inert gases? Any idea you have? Am I audible to everyone?
Yes, sir. Yes, sir.
Can you guess any guesses why we should purge argon nitrogen in the secondary steel making process? What may be the reason? Just check this one, this part.
Or homogenization.
Homogenization, very good. Actually, what happens, if you're adding some alloying elements, then it may not be like that. The alloying element will be everywhere, right, inside the steel. So you need to purge argon and nitrogen. That argon, nitrogen are inert gases. They won't react at all. They help you to agitate the bath. Agitation will be there, or stirring action will be there, right? Stirring or agitation will be there. So due to this agitation, there will be a proper mixing. And also homogenization in terms of temperature may not be same everywhere, right? To make the temperature same everywhere, we need to do homogenization by purging this argon and nitrogen. Also, this argon and nitrogen are purged to remove inclusions. Inclusion removal is very important. You will study about inclusion. Inclusion means the deoxidation products are basically inclusions. Any sulfides, oxides, silicates, they should not get trapped inside the molten steel. They should be removed. If you purge argon and nitrogen from the bottom, they will come to the surface and you can remove it. So inclusion removal, that is called obtaining clean steels. And next, continuous casting. Continuous casting, you understand, continuously we are pouring and continuously we are withdrawing the solidified steel. It is a continuous process, not batch process. The last one is finishing operation. You can understand finishing operation. You can give thermal treatment, thermochemical treatment, mechanical treatment. Mechanical treatment means rolling, forging, extrusion. You can give, right, or deep drawing. Those are thermomechanical treatment. You can say, because you can go for hot working, cold working, both, right? So you can give thermal treatment, mechanical treatment, or thermomechanical treatment to get a desired properties and shape at the end. So this is all about your steel making basically. What exactly happens in a steel making plant? Basically in steel making shop and near to the steel making shop. Then last part we'll discuss slag theory and characteristics. So slag, this is the most important part of steel making process, because if you remember, there is a beautiful line I called, if you know how to make a desirable slag or a specific slag, then that slag can make your steel. Or in make a slag, that slag will make your steel. This is a beautiful definition line, right? Because you will appreciate the role of slag here. So what is the role of slag? Slag is very important. If you don't know how to make a slag, you cannot make a desirable steel at the end. So first point is slag is separate phase than metal. Everybody know, huh? Slag is separate than metallic phase. In pyrometallurgical processes, we have two phases, metallic phase and slag phase. Slag phase is different, metallic phase is different. Metallic phase, if you remember, metallic phase means only elemental forms substance will be there, right? But in slag, it contains oxides basically, or it contains compounds basically, compound, either oxides, sulfides, phosphides, silicates, all are compound form, right? But in metallic phase, always elemental form will be there, right? If something in metallic phase, if something become compound, it will go to slag phase slowly. And we understand slag is lighter than molten metal or molten steel here, and it is immiscible in steel. So these are the two important points. It is immiscible in the steel and it is lighter. So during steel making process also, slag remain on the top and the steel remain at the bottom of it, right? Because it is immiscible and lighter. Right? Then slag formation, we know how slag forms in steel making process. Actually, we are blowing oxygen into the hot metal and it is generating oxides, compounds, and also generating some sulfides. Fine. So those oxides and those sulfides react with the flux, which we are externally adding into the process. So that will give rise to formation of slag. Right. Then steel making slag. So the definition of steel making slag is predominantly oxides, mixture of oxides, and small amount of sulfides and phosphides. And already I talked about some oxides are acidic and some oxides are basic and some oxides are amphoteric in nature. And amphoteric. Then synthetic slag. Yeah, this is a very good. Sometimes people ask what is synthetic slag. Synthetic slag is a slag. Actually, it is not produced in during the process. It is we are intentionally producing a synthetic slag by adding lot of oxides together, and it has a significance during the secondary steel making process. So synthetic slag are basically used during the secondary steel making process. Basically, it helps in the absorption of inclusions. I told you the inclusions. Basically, during the deoxidation practice, inclusion forms. So that can be removed by using synthetic slag. Synthetic slags are used basically in the tundish. I think you don't have idea right now about tundish metallurgy. In the recent lecture, you can get to know what is tundish actually. So in the tundish, we add this synthetic slag to remove the inclusions, basically. And it acts as a barrier sometimes. So that the molten steel won't react with the atmospheric oxygen. Okay, anyway, slag property. So the property of slag is very important. Property of slag means physical property of slag or chemical property of slag, right? So physical property of slag means melting point, viscosity, density, right? And chemical property means basicity, oxidation potential, sulfide capacity. So these are the important chemical properties and these are the important physical property, right? Can you tell me, it will be better to tell melting point or liquidus temperature?
Sir, liquidus temperature.
Liquidus temperature, yeah, very good. Why? Can you justify that?
Sir, because there are lots of other elements which will define the melting point of a substance. Because
Yeah,
if
yeah,
we
very
are
good.
telling a melting point, then it is for specific composition. But we are not deciding the composition here. It's changing every time.
That is good. And the thing is, it is not a single component. No, it is a multi-component system. Slag is a multi-component system, right? Lot of oxides are there. Each oxides have a different melting point. Yes or no?
Yes, sir, with different compositions.
Yeah, yeah. If it is a single component, it is a melting point. If it is a mixture of components, so that is not a melting point because its melting point depends on various different component melting points. So it is a liquidus temperature. Anyways, And this is a very good line. Both physical and chemical property are controlled by composition and structure of slag. So this is very important. So composition of slag is important and structure of slag is important. Right? That will decide the chemical and physical property of the slag. Okay, I will end the lecture here. We can continue after dinner if possible. Any question you have so far?
No, sir.
Okay, fine. Thank you.
Thank you, sir.
Thank you,
Thank you, sir.